this constant movement, this constant timeline, is that maybe the most challenging aspect for machine learning engineers when they're trying to implement streaming applications?
Industry standard for now is that going from a batch prototype, that means static data, data scientists showing a dashboard, to a live streaming deployment of the same dashboard updating in real time is roughly 10 times the effort. Reactivity is all about the art of dealing with changing data in such a way that you don't have to worry too much about the processing part when data changes.
Adrian, welcome back to the Super Data Science Podcast for your first full-length episode. You were here. We met at the Open Data Science Conference West in San Francisco back in the Northern Hemisphere autumn. And you recorded an awesome episode on liquid neural networks. That's episode number 632. Fascinating technical topic. Adrian, where in the world are you calling in from today?
So I'm based in Paris. I'm calling in from just outside Paris, France, from a place which used to be the countryside, but is now meant to be the Silicon Valley of France.
Oh, yeah.
Paris
And it's the Pathway office. Is that right?
It is.
Nice. And so you're the co-founder, and you're the chief product officer at Pathway, which is a reactive data processing framework that allows people to create real-time data products much more easily. So I know that we're going to get into a lot of what Pathway is, but before we even get into that, I want to let our listeners know that you very kindly offered, you're offering 10 free hoodies to the first people that respond. So when we release this episode, it's always on Tuesday mornings from a North American perspective. It'll be the morning. And I post on LinkedIn from my personal account a big post about what the episode is going to be all about. When I make that post, I'll include in it to say the first 10 people that ask for a Pathway hoodie get one. And you're offering to ship them anywhere in the world. So that's very kind. Thank you, Adrian.
It's our pleasure entirely. These are really good hoodies. We hope you'll be satisfied.
Yeah, apparently their hoodies so good that you'll want them even if you're in a very hot climate.
That's what they say. We also do software, but we do hoodies most of the
time. Yeah, so when you guys aren't designing hoodies, tell us about the software that you make. So you have a reactive data processing framework. Yeah, tell us what that means and what can you do with it.
Yeah, sure. So reactivity is all about the art of dealing with changing data in such a way that you don't have to worry too much about the processing part when data changes. I think if you want to be formal, there's probably some dictionary or encyclopedic definition of reactivity, which will tell you it's about being declarative in a programming sense, like explaining the logic without imperatively saying what to do at every step of a data transformation, but of explaining the rules in like a functional programming sense, explaining what the transformation should be. And that's about the essence. So it's really combining the ability to be declarative with the ability to process data changes automatically in an efficient way. So that's a notion known as incrementality. It's the idea that when data changes, you don't have to do a full recomputation of all the models, of all the things that you've designed in your data pipeline or in your data science project. You just do a minimal recomputation to react to the way data changes. So I guess the most best known example of a reactive system out there is your spreadsheet. Call it Excel sheets, whatever is your preferred software. You define the rules on the data, and when the data changes, the cells update. So this is like one example. It's a data processing example. It's not one that scales very well, but it's an example of data processing. And actually, since spreadsheets came in, I think nobody has been able to fully replicate the success of this type of approach at scale. And we come with our attempt. I should say that reactivity is a concept that's very well known, very familiar to front end developers.
Right.
If you've worked with JavaScript, TypeScript.
Yeah. It's even probably the most famous framework right now for front end development is called React.js.
It is. And the others that don't have React in their name are reactive nonetheless. So all of them are. And like the kind of place this has got front-end developers to is that when designing a front-end system, you don't have to do as much event handling as you would do 15 years back. So some of you may remember having to write things like on-click events to describe the state change of a button, when you click, but you had to do it and so on. And these days in front-end development, you don't do it that much. Surprisingly, in data processing, even data processing at scale, if you want to work in a real-time setup, you want to work with data that changes or with streams of event data, a lot of the time you still find yourself doing the equivalent of on a click do or something like this. The backend equivalent is on data change event or on arrival of a certain packet of data do. And this is something that has to be done behind the scenes, no question about it. It's just that we don't necessarily want the developer, be it the data engineer or the data scientist, to be exposed to the pain of doing this type of on something event processing. After they've already had to put a lot of effort to design their system just to get their job done to create a model or
hmm
something. So,
So it seems relatively straightforward to me to understand. In the case of a user interface, we have a browser app that is reactive to somebody adjusting how wide the browser is, or whether they come in on a mobile browser or a tablet or a desktop, that the website automatically adjusts, or as you're saying, to behaviors, to somebody clicking on something and the application reacting to that. In the case of data changing, what does that mean? Like, how do the
mhm.
data change that are flowing into a machine learning system? Like the machine learning system, it could be handling different kinds of data types, or what is it? What, yeah, what does it mean when the data changes?
So the most straightforward setup, I'd say, is when the data type does not change. You just have to deal with new data of the same type, just data that you haven't seen before. If you're a data scientist, like the ideal world is when the data sample that you're working with
hmm
is the
hmm
actual data that will
hmm
be that has to be analyzed.
hmm hmm
When you're in the online ever-changing world where new data comes in, this is never the case that the data sample that you look at the time of designing your model is the one for which you need to do the insight. So in some sense, at least the testing data, the real world testing data, is not known to you. Sometimes, even in real world scenarios, it may be the case that the training data, so to speak, is not known to you. So your model is retraining itself or adjusting to new incoming data.
Online
Um,
learning.
Online learning and things like this. So this is the general setup. If you like diagrams, you can picture data inputs on the left, data outputs on the right, and your data pipeline in between. And whatever fresh events come in from input need to be taken into account. If you want to make life fun in an architecture sense, you can also put a human in the loop, somebody who's
hmm
providing feedback on how your model is performing and saying, actually, we should tweak this parameter. For example, it's like, it's today we need to adjust because it's a rather special day or something like this. Some parameter for your forecasting, prediction, anomaly detection model. Or the user can say, actually, in the training data, there was a mistake. and we need to pull out a training data point and say, look, this should never have been trained like this, or the label should have been changed, or a certain class of automated inputs which entered the system may have entered with incorrect values. For example, there was some confusion between M denoting meters and miles. The data that input needs to be rescaled, and you have to sort of unlearn the data that came in previously and relearn with the new data. So anything is kind of possible in the sense of data changes for the system.
So, in the past on the podcast, we've talked about issues around things like feature drift, where
Mm-hmm.
you design a machine learning model to be able to handle the kinds of training data that it's encountered in the past, but then the real world changes. And so the inputs, the features that are coming into the model, so in your, you described a flow from left to right. So on the left-hand side in those data inputs, the inputs are fundamentally changing. The structure of the inputs is changing. So even though, as you say, it's the same data type, it's still a 16-bit float value, or it's it's an integer, whatever.
Mm-hmm.
The features are now in a range that are outside of your training data, because the world has changed. So, is what you're describing, this reactive data processing? It's designed to allow your machine learning models during online learning to be able to adapt to this feature drift automatically.
So this is part of the story. I think reactive data processing should be treated very broadly, and if you start implementing it in a larger system, like data pipelines in enterprise, which are processing event data. The start of the story is in data engineering. The end of the story is in analytics. In order to benefit fully from this type of framework, from real-time data processing in general, it has to be put into place like end-to-end, or at least it helps to put it into place end-to-end. And the models, the analytics models, the machine learning models that come in are kind of the cherry on the cake, but the one that allows you to do a lot of value. So we make sure to make this possible. This is just to say that in a strictly machine learning context, this would be a very let's say, a good application, and at the same time an ambitious one when you get to models which are sufficiently advanced to be very much aware of problems like feature drift versus, let's say, an intermediate class in somewhere in between engineering and more advanced machine learnings of models which have a certain time horizon, a time window in which they learn, and they are updated as this time window moves ahead. I'd say this is like a first more natural example in a real world project that you'll be looking at the last few months of data, some kind of moving average on the data, and trying to adapt to it. So indeed, it may be the case that we get into questions of models getting outdated and needing updating, model versioning, and so on. But this is some heavy machinery which comes in relatively late in the project. A lot of the time, it's actually possible to just adapt to the structure of the data itself by having a model which knows how to adapt to the structure of the data, which has this capacity to encompass horizons, to be somehow scale free with respect to the nature of the data.
Nice.
Every company wants to become more data-driven, especially with languages like R and Python. Unfortunately, traditional data science training is broken. The material is generic. You're learning in isolation. You never end up applying anything you've learned. Posit Academy fixes this with collaborative, expert-led training that's actually relevant to your job. Do you work in finance? Learn R and Python within the context of investment analysis. Are you a biostatistician? Then learn while working through clinical analysis projects. Posit Academy is the ultimate learning experience for professional teams in any industry that want to learn R and Python for data science. 94% of learners are still coding 6 months later. Learn more at posit.co/academy.
So let's try to make this example a bit more concrete by going into
Mhm.
a specific use case. So you and I were planning on later in the episode talking about global supply chain networks and how the pandemic kind of broke these, and how reactive data processing combined with IoT, Internet of Things hardware could help make rather global supply chains more resilient to abrupt delays and shocks. So maybe let's dig into that specific use case now, so that as we kind of address other questions around how reactive data processing works, we can like tie into the specific concrete example.
Yeah, so actually, we started Pathway working closely with actors in the logistics industry, working to improve global supply chains and global transportation patterns. Logistics is a pretty fascinating area because if you look at the importance, the value, and the scale of the industry, it's about something like 10% of the world economy.
Oh
So
wow.
it's really big. It's highly concentrated, and a lot of the value is in international trade, uh, trade that goes on containers, trucks, large vehicles, and it's in some sense, from a data processing perspective, when we were starting, this was largely terra incognita. It was a rather new world of analyzing this type of data patterns related to logistics assets. What IoT gives in this setting is the ability to trace moving assets, be it containers, trucks, parcels, you name it, end to end. That is, you attach a sensor and you have the whole trace, the whole tag of an asset that's moving. This leads to an interesting situation in which something like 10% of the world industry has some of its most important data lying in one data schema, one data format, which is essentially a big table of events related to moving assets. It's a table whose columns are something like timestamp, asset ID, location XY, GPS latitude, longitude, and the type of event that happened, whether it was a kind of just a measurement of a location, whether it was a measurement performed by IoT, for example, of temperature, pressure, door opening, some kind of alert. And this kind of table actually captures a lot of other things in logistics as well. For example, if there's a facility where your parcels are being scanned, all such scan events also enter in this type of table. So you have one kind of input data table, data schema, which seems to capture everything that's happening, but which is quite unusable from the point of view of business intelligence, analytics, and process monitoring and observability used directly, just because it's super hard to query. It's hard to express in a language such as SQL a query on the data, which would extract what's important. And the important questions are related to process, things that are happening. So, for example, a logistics client may be interested in knowing what are the risks of anomalies of a given type, like shocks, happening to your sensitive pharmaceutical shipments in the next 2 days on a given route, let's say Rotterdam to New York. And if you look at the data inputs, all the information is there. We've given a lot of man years and a lot of patience. You could probably get it in the end by hand, but it's not all that easy to extract and automate over global processes. So that's where we started. We started working with a process of enriching this data automatically, converting the schema to add structure to it in such a way that it's actually possible in real time to get an enriched data schema which is queryable and which reveals information about the process. There are a lot of aspects to it related to, first of all, trajectory mining, understanding how things flow, uncovering automatically the key locations. So this is like automatic geofence detection in the lingo of the sector. It's about understanding anomalies, congestion, delays as they happen, or even before they happen, and putting into place predictive models. So there are many steps here, and already getting all of this done in a batch setting, a setting where you have all the data available, like just historical data, is a challenge to express it cleanly and to get an analysis of a snapshot, so to speak, of the data, and it gets extremely complicated if you, on top of this, you would want to manually create logic in a way which would take into account changing data. It becomes a task which is both tedious, error prone, requires a lot of duplication of logic between the, let's say, the offline case and the online case, and so on. So our effort was, on the one hand, to automate this, and on the other hand, also to figure out what parts, what models in machine learning, what transformations of data are actually amenable to this type of approach. Basically say, forget what cannot be done, focus on what can be done here and now, and make it possible to make this robust. So just to give you an example of the types of data processing routines that we have, we've designed to work robustly across different modes of transport, be it ship, truck, train, container, or vehicle, even working for small assets like parcels, sometimes with animals, sometimes with public transportation. So basically, to have models which work with very little or minimal awareness of what is actually being traced, what type of asset is being traced, to allow changes to this process, to allow new modes of transport to be introduced, to allow changes to the logical process. If you follow like what your couriers and delivery people are up to before Christmas, it's actually amazing how the whole logistics network adapts. There are new depots being opened, temporary depots. There's changes to the process. Things are happening completely differently in peak season. And if you want to make sense of it, you have to have a system which is able to take into account these changes as they happen. New depots open. Okay, it's not something that you will want to manually introduce. It's something that you have to kind of capture from the data.
Wow. Okay. Yeah. So that is very concrete and crystal clear. So these real time data products, reactive data processing frameworks like Pathway allow data models to be applied to complex systems like a delivery system, like the global supply chain network. And it's reactive automatically to things like vastly greater volumes in peak season around Christmas time, heading into Christmas time, including things like hubs coming online that previously weren't there. And so you don't want to be going to your data scientist and saying, "Hey, a new hub opened up um, yesterday. It's December 1st, and a new hub opened up. We need you to retrain all of the machine learning models that we had to be able to account for this new hub." And then the very next day, two more hubs open up because we're one more day closer to Christmas. And you're like, "Sorry, data scientists, we got two more hubs. We need to retrain that data model again." And every time the data scientists are like, "Oh, this is going to take like a week." And so instead, with a reactive data processing system, it's flexible to these kinds of changes automatically.
Yeah, and that's exactly the spirit. It's kind of also changes the whole workflow, the way the non-technical user can interact with the application. So you can have an expert in the domain who is working with a system, and rather than asking data scientists to update models, they either get, in the case of a simple model, you can actually redeploy the model as it happens, or in some case you get a question whether you want to update your model or you update your data. So if we talk of these hubs that open at the beginning of the day, whoever's managing the dashboarding part of the solution gets information that we have detected 20 new hubs which opened since yesterday. Please approve or correct errors. And essentially, the work of this person is more in fine tuning or fixing things that were not detected with, let's say, 100% accuracy, or performing small corrections to the automatic labeling that's being done, rather than actually introducing or driving the change process manually. Just to say, from our perspective, this is where we started out with. So we started with one concrete data product in logistics, and this is our flagship data product. It's being used by major companies, freight forwarders like DB Schenker, which is third worldwide largest freight forwarder in the world, by the French Postal Services, which also have a wide international network on this, operating in other countries as well. So the kind of use there is what we see and we feel. At the same time, what we are delivering is this ability of data scientists and data engineers to work in the same way as we do. So we want to share the experience. We want to share the experience both with everybody, with the wide community, and also with the data teams of our clients, to work closely with them, to allow them to modify the data pipelines, to include new data sources. So it's really very much about giving this full development experience, and having it work like having it work as a developer tool.
Nice. That's crystal clear. And so now that you have expanded beyond that initial use case, your most developed product around global supply chain networks, what other kinds of use cases are people using this reactive data processing for?
So this is interesting because the use cases expressed in our terms. So I'm assuming we're discussing data here, and data audiences are extremely horizontal. They're not like tied to industry specific verticals. So many of us change jobs, between different companies, like going from healthcare to let's say whatever, transportation or manufacturing. But the kind of data of use cases that exist from a data science perspective are pretty consistent throughout. There's anomaly detection in real time, predicting anomalies, detecting fraud, which is a type of anomaly detection, and recommendations, online updated recommender systems. Some further ones which do appear in some cases are around forecasting and time series forecasting, plus let's say some that are further down the stream. But in some sense, it's also a question of the most immediate value. For most immediate, the most immediate pain point is really the one where you need to act quickly, and the time horizon related to anomaly detection, to alerting, is just much shorter than the time horizon related to updating forecast models, typically.
Right. So I can imagine financial applications, for example, where you're detecting fraud would be a really great use case.
Yeah, financial applications are a nice one. It's also interesting that you have several horizons in the financial application. Let's say you're doing real-time transaction processing, be it more on the major card processing actor side or on the DeFi side. Either way, you have a window of opportunity of 2 to 3 seconds to block certain types of transactions, those where the user is still not getting impatient, and then a post processing like window where you can still undo some transactions or try to fix things, but things get worse in a horizon of seconds to minutes. So this time horizon is actually very short in this case. One that many of us in data know is related to monitoring of health of systems, of processes that are going on. So things around observability in processor server monitoring and because the system's reliability field. This is an interesting use case, which is very special, but it also gives, I think, an idea of the kind of alerting that we are looking at. If there's a human operator involved, you want to react within your SLA time window, which will typically be something like 15 minutes. This is the number that comes up most often, given guidelines of major companies. So you have like 15 minutes to react, and the kind of data that you have is how many minutes of this 15-minute window that you as a human have to react are eaten up by the system being slow to give you the information. If it's more than 5 minutes, you're really, really angry. But maybe you could go from 5 minutes to 3 minutes to 30 seconds. Sometimes you increase the value there, and you can actually do way, way better if you get this alert faster.
Cool.
Are you stuck between optimizing latency and lowering your inference costs as you build your generative AI applications? Find out why more ML developers are moving toward AWS Trainium and Inferentia to build and serve their large language models. You can save up to 50% on training costs with AWS Trainium chips and up to 40% on inference costs with AWS Inferentia chips. Trainium and Inferentia will help you achieve higher performance, lower costs, and be more sustainable. Check out the links in the show notes to learn more. All right, now back to our show.
All right, so now that I have a clear idea, and probably our listeners have a clear idea of applications of this reactive data processing, let's dig into it technically in a bit more detail. So a big contrast that comes up a lot in the context of reactive data processing, and that even came up in a recent episode number 661 with Chip Huyen. So there's this idea of batch processing versus stream processing. And so what's the difference from a machine learning perspective between these two processing modes, batch and streaming, and how does that tie into reactive data processing?
So actually, the answer that would be taken from a reactive data processing perspective is that if you look at time as something that appears in your data, if time is an important feature for you, then it's an important feature for you, and whether you are in batch or in streaming, you should handle time. If time is not a feature in your data, then you should have the privilege of not looking at time, and the system will be able to handle things for you. So just to give a very concrete example, let's take...
Yeah, please. You just blew my mind.
Let's take...
if you have the luxury of time not mattering.
Yeah, and it's actually something like time not being a feature means that, for example, look at spam. What's a spam message? A spam message is the same, like you see spam, you recognize it, you treat the same thing as spam today as in a week or in a month. Right? Spam is spam. It's like there's no time aspect related to spam. However, it might be the case that depending on how the spammer is behaving, you may be able to detect a spam message at some point or not. For example, when somebody is sending a message for the first time, the spam filter may still not be aware that it's spam. But after a message has been sent 10,000 times, 100,000 times, your model for spam detection or a spam detection filter will be able to figure out that something is amiss because of the behavior of the spammer. Your messages are classified as belonging to a kind of cluster component somewhere, which is spamish, and all of this can be classified as spam. Right? So in this sense, what's happening is that the incoming data allows the model to improve its classification decisions over time. However, the logic of the classification process as such is largely not tied to time. It can be Time doesn't have to play a role in it. You can do a lot of things without thinking about time. So what the answer is in a reactive setting is that you could imagine that you have access to all of your data in batch mode. Basically, you have all of the input. You process it. You give the answers, and these are the best answers you can have because they're answers given with all the knowledge. And then if you launch the same code in a reactive system, it'll be doing its best to maintain answers which are as good as possible given the current knowledge. So at the end of the day, it will converge to the same outcomes which you would have had if you had had all the information initially. And on the way, it'll be doing kind of a best effort classification based on whatever partial knowledge it has. So it may happen that a message comes into your inbox, call it Gmail, for example. Suppose Gmail has a reactive spam filter. It's classified as non-spam, but 5 minutes later, when new information arrives, it becomes automatically reclassified as spam and can be pulled from your inbox.
Wow.
So this is the idea that you don't have to worry about the deployment, the way how things are going to be, run, rerun. You don't have to worry about how the data streams unfold over time. You just design the logic, and you put it in the system, and you somehow you are released from the worry about of the streaming data.
Cool. All right. So I know we're getting there, but so how does this? How we haven't like concretely defined this difference between batch and streaming.
Yeah. So batch is the concept that your computation is run and scheduled. I think batch, orchestration, scheduling, these are concepts that all go together. They're part of the same mindset. It's one where you look at the data as it is now. You run a computation on it, or you run some processing on it. Something happens. 8 hours later, 24 hours later, the scheduler says, rerun the batch. You rerun the batch, and things get updated. So it's this type of mindset.
To give maybe an extreme example that gives a clear sense of this, when people have been using ChatGPT since it came out in late 2022, it has a modal that comes up and gives you all kinds of warnings, like this is experimental. But one of those warnings is that the data hasn't been refreshed since 2021 or something like that. And that's because the underlying model, so up until very recently at the time of recording, the most common natural language model that people were using under the hood of ChatGPT was GPT 3.5. And this GPT 3.5 had been trained on a batch of data that was current up until 2021 at some point. And so there was this big batch of data, and then it took, who knows, maybe weeks of training, maybe even months. I don't know. GPT 3.5 was so large that the whole processing pipeline could have taken months to do, particularly when they want to add in all these kinds of safeguards around using it ethically. And so that model is not streaming. It's very much the opposite. And you could take that same model architecture and update it in 2022 at some point, but it's only getting like this annual update on a batch basis. So you have these big batches of data. And so you're describing a situation where the batches could be much smaller, where it could be every 8 hours or every 24 hours that we have a machine learning model in production that is where the model weights are being updated from new data, so that things like a new hub in the delivery network that came online in the last 24 hours is now going to be handled. We have some data regarding this hub, and we can be handling it. Yeah. So this kind of gives a sense of batches and how we can have big gaps between model refreshes or small gaps. And then streaming is a completely different kind of perspective where it's like data point by data point in real time being updated.
Yeah, streaming is exactly this perspective where the data flows in a manner where when a new data point comes in, you handle it. So if I think like to be perfectly like take maybe a human perspective on batch and streaming, the inherent preference for looking at batch or looking at streaming depends very much on what world you come from. If you're more in the mainframe or static database type of thinking, you probably have a natural preference for looking at computational systems as batch systems. If you are more in the microservice design, APIs, things communicating, data flowing, your natural preference, your first approach is more around working with streaming data, and the for each type of system, whether it's around batch processing or around event-driven stream processing, has very different characteristics. In general, being event-driven has the obvious advantage of lowering latency, because you can react to new data as it arrives, so your models can update. The difficulty is in making non-trivial logic work. And by non-trivial, I mean actually doing something like a database join, which is already impossible in most data processing frameworks, to maintain a join of two data tables. Join as you would see it in SQL or in Pandas or whatever. This is something that's hard to do in real time, let's say, and that requires a special framework which has to know how to handle a join to be able to do it. So back in 2019, it was messy to do. Now more and more frameworks are catching up. But this is about the forefront in terms of tooling as what's possible, what kind of difficulty of processing is possible in real time.
Cool. Yeah. So it sounds from, I come from this uh from this background of being a scientist. And so we ran discrete experiments, and you get a batch of experimental results. And so I'm used to this idea of having like this specific table where, like, okay, experiment 1 is done. I have my set of data. It has this many rows because that's exactly how many human participants we had in this first study. And then it's just kind of static indefinitely. And I train a model on it, might and publish the results of the model. I might even make the data open source, make it available freely online, put it into the public domain, and then anybody can use my perfect table of data from experiment 1 that never changes. Um, and so yeah, so I come from um, this batch background. It's probably the case that people that are used to the kind of streaming situation that you're describing, people who are used to microservices, they're probably more likely to come from a computer science background or a software development background.
So I can give you an example, because right now we're doing some experiments on our side. We're running benchmarks of Pathway against other frameworks. So we're doing an experiment, and in some sense, these experiments, let's say, last weeks. They take weeks to run, and you need multiple repetitions of an experiment to get reliable data, to be able to take, let's say, the median of the data points or some average or whatever. But imagine you just wait for the first run to complete, the first run of the experiment. And you already have a data source, which can be like, let's say, Google Sheets or Excel. And Google Sheets is a better idea, gives a better idea, because it's kind of more online, more live, where you've put your experimental results there. And at this point, you can use whatever plotting software you like, let's say Tableau, to get some first charts out of it. And now suppose you continue running the experiment, and as new data points arrive, you get a larger and larger sample, and your dashboards are live. They get updated as the sample grows. And for example, once you've got 5 runs, a line which was a bit noisy at the beginning has kind of smoothed out, because you've lost the statistical noise level has been reduced. So your dashboard is a kind of live dashboard on top of a scientific experiment. So in some sense, in this way, you can look at a scientific experiment being done in streaming mode. The new data is coming in, it's updating, fixing the dashboards, and at some point you press stop, and this dashboard is production ready. And this I think is a good point to say that the fact that you're in streaming mode does not mean that you cannot look at data back in time. It's a bit like with most of our productivity tooling that we're using these days. We're used to the fact that you can look at the version history, you can go back some number of edits, you can go back to a past snapshot, a past version of a system. And this is especially important in distributed systems which are serving answers to requests, and you have to be absolutely sure that you are serving answers based on a consistent version across machines, meaning that you're referring to one snapshot, let's say from a few seconds, few minutes back. But if there's a problem with a snapshot, you could also roll back to a past snapshot, maybe 20, 30 minutes back, or even further. So there's a kind of notion of snapshotting of the past, but you're working inherently with a kind of timeline of things that move forward. So
is this constant movement, this constant timeline, is that maybe the most challenging aspect for machine learning engineers when they're trying to implement streaming applications?
if you were using an API which has streaming in the name, then it's an added challenge. It's a second challenge. I wouldn't want to say it's the biggest challenge in terms of uh, some kind of ingenuity being conceptually the most difficult. That would be undermining the effort that's needed to actually get something going in machine learning, which is enormous. But it is an enormous challenge in terms of system deployment, system maintenance, making sure there are no bugs, making sure this is actually feasible to run. So the industry standard for now is that going from batch prototype, that means static data, data scientists showing a dashboard, to a live streaming deployment of the same dashboard updating in real time is roughly 10 times the effort. So I'm not saying it's necessarily 10 times the same ingenuity needed, it's just 10 times the effort, at 10 times the timeline, likewise. So it's a question of cost. It's a question of some R&D risk involved, some risk that things will go wrong or that will not be moving fast enough. And afterwards, there's a question of maintaining this and making sure the system is going. So at this point, the system, if it's a streaming system, it has essentially hired somebody on the MLOps side, on the data and engineering / reliability side to make sure that the pipeline is being properly maintained. So it's a challenge to the degree that many systems never end up going from batch to streaming or from prototype to production with real-time data, because this challenge is just too much to overcome. And depending on the setting, it sometimes may be the case that the project actually brings 10 times more value if put into place in real time, or even more. But it just never happens because the cost side is too prohibitive, or the timeline is too prohibitive. And
Right.
the approach that we're taking is basically to automate the second step, make
Right.
it possible to.
So streaming can historically be 10 times as complicated, uh, but it can offer more than 10 times the value once it's implemented in production. And real time reactive data processing frameworks like Pathway are designed to dramatically decrease that 10 times complexity in getting it set up and allowing you to realize that 10 times value.
Well put, John. The cost, The cost aspect is actually quite fascinating because as we do this transition from batch systems to work more and more with streaming data, there are a lot of dimensions on the cost side which come in with a streaming system, which are not obvious. So one aspect is that the structure of expenses related to infrastructure, cloud infrastructure changes. Traditionally, streaming systems had a higher hot storage component requiring a lot of state to be maintained in hot storage, and this is only changing now. This is a cost factor which is being reduced, and the counterpart is actually that batch systems have an enormous computational cost associated with them because you are
Hmm.
doing a lot of essentially useless computation. Every 24
Hmm.
hours, you're recomputing the same things, even though maybe in the horizon of one day, 1% of your input data changed, you're doing a
Right.
100% recomputation.
Right. Right.
So in the case of of actors, when you look at your cloud bill and you take the three components, which is storage, data processing, and networks communication, let's say, if the data processing clusters, your Spark clusters or whatever else you're using to churn the data, are generating a significant part of a bill, it may be the case that moving to streaming-like systems or reactive systems, which allow you to transition through micro batching into this online world, will actually cut the bill of the deployment.
Cool. Yeah, that's really interesting because to me, it seems inherently that if you have this continuous learning, oh, of course, that's going to be more expensive because it's always learning all the time. But I hadn't thought about it from this perspective that with batches, you're retraining the entire model every time.
Yeah.
And so that is very computationally expensive. Very cool. Hadn't thought about it
There's
that way.
there are many like practical aspects to it, and one is just it's the reality around us that ad hoc instances are often much more expensive than instances that are reserved. So the rule of thumb is that if your computation is running for 4 hours, 5 hours, 6 hours during a day, during 24 hours, it really makes sense to have an instance just reserved for this, like 24/7, without asking for a new instance every time. And if you're in this space, by making this like batch computation spread out over time, you are already better allocating your resources because you get something like a factor of 4 or 5 in computational resources for free just by having more hours in the day to use. And there are a lot of possible gains which just come from this better like spreading of computation over time.
Very cool and crystal clear. So, to allow these reactive data processing operations to happen efficiently over this 24-hour day, as opposed to doing it in batches, at Pathway, you talk about transformers. And so these aren't to be confused with transformer architectures that have become really common in large language models like GPT-4, and going all the way back to the early transformer architectures like BERT. It's a different kind of transformer. So it's kind of like maybe how the word kernel is used in computer science to mean so many different things. Um, and so transformer here means something different. Although from our chat prior to beginning recording, it sounds like there is a kind of a common thread to the etymology of why a transformer architecture is called that and why your reactive data processing operations are called transformers. Do you want to fill us in on these transformers that you have?
Yeah, I guess this is a great question actually, and just to say that the name transformer is kind of controversial in the sense that obviously transformers are the T in GPT and basically one of the more commonly used words on the as an architecture in deep learning. And the kind of backstory from our perspective is that one of our friends and business angels is a co-author of the original Transformers paper. So it's Lukasz Kaiser from Attention is All You Need. And our CTO also comes from the attention/Transformers world. So it took a lot of internal discussion if we wanted to use the word Transformers in a pure data processing sense. There's not much depth to it. A transformer is something that transforms one kind of data into another kind of data. In our case, it's a box which transforms tables into other tables. We are not the first to coin this term, and I think it's one of them. Like on the data engineering side, it's pretty unambiguous, and I think for this reason we.
Oh, really? So in data engineering, this use of transformers as an operation that transforms one kind of data structure into some other format, that's quite common.
It's used by some other frameworks. I'd say that like we didn't want to coin new terminology for it. There's actually an interesting point which also helps to trace this path between data engineering and data science, is that in data engineering, a lot of the time you think of your data tables, data sources as assets. Meaning that there's certain, like they have a physical representation somewhere in the data warehouse, and when you combine them, you create a new physical representation. And to do it, you need to run a job if you're in batch mode or something like this. So there's a very physical feeling to data flows, whereas in the data science world, more often than not, you are designing a kind of block, a building block, which just it's like a function which takes certain input parameters and has certain output parameters, which is much more flexible to use. It's not tied to specific inputs. It's more composable. It can be used inside other functions. In our case, in the case of Pathway, we have support for iteration. So, for example, iterate a given transformation until convergence. So you can have a transformer which is like one iteration of, let's say, gradient descent, and you put it into a block which says iterate until convergence, and then you get a new transformer, which is like the looped version of the first one. And in this sense, something that has these like data table interfaces in and out, that's pluggable and moldable in the data flow is how we use the term transformer.
So cool. So now I understand what transformers are in the context of data engineering and of transforming some data format into another data format as part of this data flow. So why is that so critical as a part of streaming and reactive data processing?
So the kind of place which is crucial here is actually being able to express logic easily, clearly, and in a way which is accessible. And we're always somewhere on the boundary between declarative and imperative operations. So if you say you want to filter a table leaving only values in which a given column is larger than 10, you're defining a kind of block which says let the data in, and you get one table at input, an output table with the same schema but with fewer rows. So it's as if you were wiring together blocks, and the connections between these blocks, you can feel a bit as if you were fiddling with I don't know, with circuits or whatever. You're just pinning them together and you get a kind of data flow, and this is like the outermost perspective. And somehow when you look inside each of these blocks, so when you're running a filter which just leaves values with the larger than 10, you're probably doing a built-in, which is like a filter select or something like this, but you could be doing something a little more advanced, which is like applying a lambda function to every row of your table in the MapReduce paradigm. So you could be doing something more powerful. And then you could also be doing some transformations which are specific to multiple rows of a table. So this comes in a lot when the data is interconnected. For example, when your data tables represent a graph, a network, and the connections between nodes expressed by edges, which are pointers to other rows, and you want to perform some kind of local operations, for example, do a search of a given neighborhood of a graph. And there you can switch to it's more convenient to switch to a programming paradigm where your main actor is not the table, but it's really the data row, the data element, the data node that you're working with, and you act around it somehow. So you're not working with tables. You're working with individual rows, and this is what's happening inside the transformer. So if you peek inside, you have this possibility to work with individual data elements. It's a bit like it's a bit like to some extent if you define a kernel when you mentioned the word kernel. So a kernel is very much about designing a transformation which is around individual wires, and uh, the whole thing, the whole deployment has to perform has to run for multiple kernels in parallel. So it's the counterpart of this in the world of incremental reactive data processing.
Cool. And there are instances in the context, certainly, of reactive data processing where these transformer operations are themselves machine learning powered, right? And I think you refer to those as smart replacements.
Absolutely, yeah. That's really the objective, and from being a product person, I'm very much like on the developer experience front. This is one of my hopes here is to provide a seamless experience, transitioning from what you could call a relatively mundane data operation, which is defined in SQL, to one which is in some sense smart or fuzzy or machine learning powered. To give you an example, if you take the group by operation, which groups row of a table according to a value of a given column, so standard group by, this returns a certain number of groups of rows. If you take a clustering operation on a table, clustering understood in a machine learning sense, clustering also performs a grouping of data points, right? So from an interface perspective, if you use a table or data frame API to express the operation, group by, as you see it in SQL or pandas, and clustering with arbitrary custom logic, have the same API. So in some sense, for us, it's just an interchangeable box. If somebody is, for example, grouping, let's say, points in space by their x and y coordinates, they put a group by type of box, but then they change group by to spatial clustering, and then the internals pass from an SQL-like database operation to a machine learning operation, which performs a clustering of points in space. So this is like one example for group by versus versus cluster. Another is about, for example, join versus smart or fuzzy join. If you're joining two tables by name, okay, this is a pure join operation. If you are joining, but there may be typos in your names or some other inaccuracy, so you're not sure which column you're joining with which column, then you're getting into some kind of fuzzy filtering, and the API again stays the same, but the implementation is completely different, and we switch, like we make the transition from the data engineering to the data science side.
Crystal clear. Thank you for those examples. They make it very easy to understand how transformers can be machine learning powered and be these smart replacements in a reactive data processing framework. And you mentioned in your response there how you're a product person. So I think this is interesting. So we mentioned right at the onset that you're the chief product officer at Pathway. But if I dare say, your background strikes me as the kind of background that somebody would usually have as a CTO, as a chief technical officer. So you have this very technical computer science background. I know you're still hands on today, writing code, and you're in this CPO role. And so I think you might have given us a bit of a clue to the answer as to why it makes so much sense that you're the CPO. And it's because the Pathway product is designed for highly technical people. It's designed
Absolutely.
software
I think
developers.
the main goal of a product person is to understand the end user and to be like the end user. It makes things simpler, but at least to understand the needs of the end user and to be able to have a certain empathy for these needs. This is why I guess for a technical person it's easier to be a CPO of a developer product. I would say if it were not a developer product, I'd be completely disqualified. Just not kidding. I mean, it's like it's too tempting to switch sides and be part of a creative process and say, I mean, what if we could add to our data processing engine something else that and starts doing a tech push and so on. Yeah, I agree fully that this temptation exists, and it's kind of a bit of a complication always knowing how the internals work. However, being technical also means that I can actually test the product in action. I can write 5 lines of code in Pathway. I can see it. I can see if I'm able to showcase the things that we are promising ourselves. I can review some showcases or pieces of open source done by others using Pathway to see if it's all meeting the expectations that are made of it. Especially given that the state of data processing frameworks as it is such that the developer experience and the experience of maintaining them, scaling them, is one of the bigger issues, because things just either fall apart or don't work 100% of the time. So then the experience of actually introspecting, debugging is not optimal, and this is one of the bigger pains of data teams. And having time to experiment with how we can resolve these issues and work on the experience front is a major challenge and major, I think, opportunity also for the space to provide some improvements here.
Nice. That makes a lot of sense. And yeah, it's crystal clear to me now. When I was preparing for this episode, I was like, oh, this is kind of interesting. And then it started to become really obvious. Okay. He is the perfect product person because he is the ideal user of this product as well. So, speaking of your technical background, before Pathway, you were a computer science researcher for over 15 years, including at a renowned French institute called INRIA in French, and it translates into English as the French Institute for Research in Computer Science and Automation. And when you were that researcher for all those years, you published dozens of peer-reviewed papers. You specialized in things like network science, distributed algorithms, dynamical systems, and the transport optimization that Pathway specialized in initially. So, do you have like a particular area from that time, from your research time, that was that you were really passionate about? Maybe you're still really passionate about today. It seems like complex systems, for example, were a recurring theme for you.
Definitely. If you zoom out, and look at a large system where things are moving, it can be in nature with ants cooperating in the task. It can be a transportation system. Then you look at how it's built, how it works, how the local interactions drive the system. And it's fascinating to observe this from also a computational perspective and ask why it's working like this. So why is it working, and what does it achieve in this way? And can we learn from it? Can we learn things about it? Can we learn certain approaches? Can we try to transfer them into computational paradigms, or vice versa? Can we use computational paradigms to explain complex systems? I think one of the recurring themes which exist in complex systems is this ability of distributed control and coordination, which is fascinating. Another which is probably closer to the, let's say, for big challenges of both machine learning and computer science for the next decade, is one of low energy computing or energy optimization. If you look at distributed systems, they actually, through the fact that they are so distributed. They do things locally. They learn things. They improve things with relatively little interaction, little communication, little computation, and little cost. And for an ant, it's obvious that it cannot, use up more energy than it has, because it has to eat to get this energy. So it's kind of optimizing as well for the computation effort. It cannot have a bigger brain, because that would eat up its sugar. So there are things that trade-offs in nature that are driven by energy. In the let's say computing world, especially in the deep learning world, this is something that's kind of acknowledged, that we are not optimizing for energy, and that a lot of these computations are done in a way which just gets things done with by scaling resources up, scaling cost up. But since it's so important, we don't think about the energy impact. And actually the incremental way of computation, and also streaming computations, are more energy efficient. So it's somehow more natural for me to be in this space, which cares about the amount of data updates that are happening in these systems, and doesn't just recompute everything from the beginning.
Right. The ant brains in a streaming processing system don't need to be as big, because they're just online making decisions, one little piece of food at a time.
See,
One little next step.
fascinating. It's quite fascinating with ant brains. The more external storage an ant can rely on, like leaving pheromones, the less it needs to store in its head. If it cannot rely on external storage, like because it's too hot in, let's say, the Israeli desert, then it has to do more computations, and they do rely more on internal storage, and for brain swells up. So these surprising trade-offs between like communication, storage, and computation happen in nature, and they're very neatly captured by a lot of those models. So it's kind
That's
of
so cool.
So yeah. I guess there are many challenges that nature and that complex systems are remarkably good at it, that we haven't quite grasped. One of them is the ability to forget. This is one of the things that many natural systems have. They just naturally forget things they've learned, or they unlearn things. This is something that's not super easy with deep learning models. So it is more the area where lightweight models, or models which have some kind of ability to add, delete data points, that have an edge in this area, and it's somehow
rich opportunity for more research there, for sure. And so you made this leap from all these years of research into being a startup founder. How did you make that leap? And is there anything that you miss from being a researcher? It sounds like you still get to do a lot of fascinating research in the role that you're in.
Definitely, I get to miss the frustrating part of being a researcher. So, one thing that I've discovered is that it's actually gives more joy to deliver code, or small showcases around code, which is open sourced, than to focus on the full effort of writing papers. Maybe GPT-4 will change that, and actually the paper writing part will be taken care of, and we just have to focus on delivering the essence for now. But there are many exciting challenges in what we're doing now. That's true. I should say I'm not completely new to the enterprise/startup world. Given that something like almost 20 years back, I started a programming community called spoj.com, spoj.com, which grew to be, in its day, one of the largest competitive programming communities. It was we really did it for the excitement of actually getting people to use to learn competitive programming, to boost their skills. But we also needed a lifeline for it, and interestingly enough, the lifeline, the revenue channel there was through enterprise who were interested in putting into place a similar framework for their enterprise training programs in what was known as algorithms at the time, and then started being called data science, but with a gentle migration around 2010. But this was also an interesting experience for me, like drafting my first contacts and doing my first sales, and at the same time having this enormous opportunity, which was to drive a community, be part of a community, take feedback from a community, and to learn the things that I sort of need to make the product better.
Nice. Very cool. I was hoping to speak about Spotcom, so I'm glad that you managed to tie it in there. And so, given that you are still hands-on today, so despite being in the CPO role, very senior role in a fast-growing startup, you still manage to make time to be hands-on day to day. I'd love to hear what your week is kind of like, what kinds of roles, what kinds of hats you have to wear over the course of the week. When there's product design aspects, there's programming aspects. You make podcast appearances, conference presentations, that kind of thing.
Yeah, there's multiple hats. There's the hat of the product person, and that is already many shades of one hat, because the product person is all about collecting input about features which comes from outside. That could be from outside, meaning from users who are happy, unhappy, or expect some prioritization, or just have some comments. Comments from clients which come in through sales channels and so on, and somehow aligning these needs with what is actually feasible, what is proposed by the CTO, by the development team, with a longer term roadmap, which is kind of originates from us and from what we would see in the system. So somehow being able to make an informed prioritization decision about the different features, elements, aspects that come in is part of my role. It's an interesting place to be, because when part of your product is essentially a framework which has an API, your features are like code in a way, and then this means it's actually way closer to code. Another hat is about actually being able to work with the community, the users who are excited about the product, and to be able to either help them, or at least understand better where they are excited, and see if we can make the product meet expectations. So this is very much about both making reach outs, which are maybe not too overwhelming, just to say basically, hey, we are there. If there's anything we could do better, we understand that the framework is relatively new still, so it's robust, but you don't have 10,000 answers on Stack Overflow to guide you. But we're here for you. We're here on Discord. You can exchange with us freely, and like get answers probably sooner, and actually also have like 10 excited members of our development team who are able to help guide and potentially come up with new ideas together. So this is pretty exciting as well, to be part of the animation of this. One thing which I've done for Pathway, and which I know some organizations, we're not the first to do it, so I know some organizations have done it. One organization that has done it is GitHub. We've pushed a lot of the workflow into a combination of GitHub with pull requests, with content creation, for example, through Markdown. And if you imagine that you have a monorepo base which includes your code, your website documentation, and your content pieces, this means that there are no barriers in the workflow between team members who are more on the marketing side, content marketing side, or on the side of actual creation. Anybody can contribute on a fair basis using the tooling. There's a certain onboarding effort which is perhaps higher than just with platforms that are not meant for developers. So you have to devote 2 hours at the minimum to onboard every new team member. But once the process is flowing, anybody can contribute, and it's kind of transparent whether you're contributing to the code base, to the documentation, to the content around it. It's much more natural that the key developer will say, hey, we are not explaining this right on our website, let me fix it. And likewise, somebody is not just writing an article or a content piece about it, they're delivering a full executable piece of code, which can be compiled during a CI/CD process into something that goes live as an article on our website, and also tested in the process whether the latest version of the framework doesn't it's not broken, or that there's no issue with things executing properly, so that we can be absolutely sure that our content meets developer standards and we deliver quality.
Yeah, a lot of different hats that you have to wear, of course.
Yeah, I tried to reduce this one. It's something that you can pull off probably only in a developer product oriented team, but one that I highly recommend if you happen to be doing one. Just make Markdown the language in which people talk to each other, technical and non-technical.
Mm-hmm.
You can do basically everything there, from websites. In some sense, code as well, or code that generates Markdown, and drawings, anything is possible. So you start feeling like one big Wikipedia and one web of knowledge, and everybody's kind of interconnected.
Cool. Yeah, it sounds like a great way to work. And I have some kind of experience with that in a smaller scale, where the first book that I wrote, Deep Learning Illustrated, it's in LaTeX, so not Markdown, but we did everything in GitHub. So I had Grant Baileyveld, who works on my data science team at my machine learning company Nebula. He was a co-author on that book, and we were able to push updates and be able to very easily comment and be able to track changes through that kind of system. And I thought it was really intuitive and straightforward, and gave a great record of how things are changing in the system. So what kinds of, other than this GitHub trick that you're suggesting for teams to work with, what kinds of tools do you use daily? Like, what's your programming stack like personally?
So I try to be hands-on, but I'm already like in between the two worlds. I don't have a super advanced stack. Just to say, I use one laptop screen, so this says something about me. If I'm working on one screen, it means I'm like a developer, but not. I wouldn't be able to aspire to certain circles. But for one of the things we have in our setup, it's a remote setup, which means that the everything is set up for remote development. So everything is working on the same developer machine that's shared in the team, which means that I'm using the same setup as everybody, which is a stack meant to be productive. We do have some preferences in terms of IDs. I'm usually a VS Code person myself, like most of the team, but this is just the front, and the rest of it is what comes through with our tech setup as defined by our CTO. So I get to benefit from this. And actually, having a remote work setup is something that comes through, and having all of the team on board with it, including, for example, the persons who are doing sales demos, to be able to have this workflow in which you can provide a demonstration on a remote machine that everybody has access to in a specific place. It kind of makes it much smoother to have the workflow going all across the team.
Nice. And so that tech stack that your CTO defines, what's the core programming language, for example, at Pathway?
So Pathway is a Python front to Rust engine. We are neatly between the two. In general, a user of Pathway stays on the Python side, has the ability to use SQL, but which is compiled to Python. And then Python is meant as the language for expressing most of the logic. It largely how to say, it compiles out of the equation, in the sense that the Python code disappears. Sometimes some function calls survive, but to the extent possible, the Python operations are replaced either by Rust calls or by Numba, depending on the case. So it gets low level and GIL lock like lock free and so on. So there are no bottlenecks there, and the computation is taken care of on the Rust side. So the team is largely either on the Python side or on the Rust side. We do have the enterprise offering, which also includes a dashboarding layer to be able to present nicely interconnected dashboards which allow for data set exploration on top of what's made available by Pathway. So Pathway does the data enrichment, puts forward tables of data that are ready for business intelligence, for business analysts to work with, and we demonstrate this through a SQL layer with several hundred dashboards, depending on the data model and logistics, several hundred that we can propose to clients or to even data engineers, data teams on the client side to customize for their own needs, or that we can customize. So there's a certain SQL layer to it as well. So.
Mm-hmm. So the Python makes perfect sense to me as what you describe as the front end to your product, because if this is designed primarily for data scientists, machine learning engineers to be using, Python is the lingua franca of data science and machine learning, so it makes perfect sense. When you were deciding to work with Rust behind the scenes, so it's a functional programming language, it's one of the most popular functional programming languages today. But how did you make that particular decision that this would be the right language in the backend?
I would say that the decision took itself, because at the same time, several people with similar mindsets, some of them on our team, some of them also involved in open source projects, decided to make Rust the language of choice. It has a certain number of advantages also from our perspective, in terms of the quality we can deliver, we can be sure to deliver. But just to say that, let's say the Rust ecosystem has grown to a degree where it's actually just as easy, if not easier, to find a data stack with a Python front end which has a Rust backend or Rust data representation. Polars, for example, as a pandas replacement. This means that we're not losing anything by having to interface just a bit more to the C part of the world. It's still possible. It's just not a big deal for us to have a slightly more complicated glue to C libraries. It's not that it would be a major argument in the discussion. And other than that, if we have folks who are on board, who are willing and happy to use Rust and deliver better quality in Rust, it's a big gain. There are some anecdotal places where Rust safe typing is causing us some extra work, but at the end of the day, everybody is happy that it was there. So,
Right. Got it. Nice. And so we know from this episode and also from your previous appearance on the show back in episode number 632 that you're a brilliant person. You can go really deep into the technical weeds on a wide variety of topics up and down the technical stack, from the low end code all the way to having a product work well for a user. So I think a really interesting question for you is if there is some kind of approach that's up and coming. It could be, maybe if it happens to be data science, that'd be ideal, but some kind of approach or technique or tool that you think is emerging that our audience should know about and be excited about in the years to come.
this is actually a big question, and now you've made me feel like that I have to take care of the predictions I make, because like 10 years from
Well,
now, and we
yeah,
go.
it could be
But
something, just something that's happening now,
yeah,
that our audience should know about, that maybe they wouldn't hear about elsewhere.
I think one of the things that I should say as a product person is that productivity is important, and the kind of dive around productivity that's been uh, the Silicon Valley DNA. Essentially, it's like everybody reorienting towards productivity is here to stay, and this is something that we see as well, also with the let's say the B2C applications of artificial intelligence. They're very much oriented towards increasing the productivity of people. So it's actually like B2C or B2B from the sense, from the point of view of being a productivity tool at work, or a productivity tool in our personal lives. And this is still there. And I would personally also want to see the aspects of um, growth of learning methods that kind of counterbalance this with, for example, energy efficiency, or the ability to do low energy computing, and to take into account um, certain certain other aspects of machine learning models beyond, let's say, what LLMs are capable of delivering. So I think I'm one of those who will be pushing for the so-called niche, in the sense of the number of applications that you see, but one which has an enormous value tied to it, from the point of view of both data processing and enterprise, and behind delivering value behind the scenes, and helping guide people, organizations towards more informed decisions, towards better insight. So it's more the data insight part of the world that's kind of, I don't know if this makes sense.
Right, right, right. So your, I think your main point is that there's a lot of focus on productivity. So things, of course, like ChatGPT, this is seen as a productivity tool. And you made the
Yeah.
joke that maybe this makes it easier to write papers as an academic. But what you're saying is that there's still a big gap in being able to get insights automatically from data.
I'd say this is the case, and I'd say we are missing something. We are missing some blocks. We are missing some bricks to be able to bridge the two worlds for the next 5 years. I'd say that the type of insights that we'll be getting will still be based on pre deep learning era models predominantly. That is the ability to put these models which into place in the right way, to deploy them, to make them work from an operations perspective, MLOps similar correctly. That's the big effort. And once we've bridged that effort, we will be left with this question whether we can get human level insight out of a system that's performing too much data analysis for a human to actually to churn through. So here we're still very much in the range of decision support tools on the enterprise side. We have not made this transition from decision support to like something further than this. And I think it's because the ingredients missing. It's not just that nobody's dying. It's something's missing.
Nice. Cool. I love that insight into the missing insights in automation. All right. So, Adrian, I've already taken way more time than I promised you I would. So, thank you very much for being generous with your time today and sharing so many of your insights with us. at the end of every episode, I ask for a book recommendation. Do you have one for us?
Book recommendation. Wow. For book recommendations, off the top of my head, actually, if you mentioned Rust, and we started talking about learning Rust. If you want to learn Rust, then the Rust documentation is kind of like a book, and I think it's actually an amazing experience. So this is just something spontaneous, just to say spontaneously that the Rust book is there, and it's a way where the difference between a documentation and a book has blurred itself. That's one of the reasons why I like Rust. But in terms of like looking at my mini bookshelf in this office, I'm, as you said, I'm a complex networks person. So anything related to complex networks always is a good thing to read. Complex networks are everywhere, from real world systems, social networks, our brains, everything here is a complex network. I'd say an introduction by Newman and co-authors is always a good thing to do if you haven't read it. And some of the more recent works out there, John, I think you may have actually a better overview here.
Yeah, I don't know if I have a better suggestion on complex networks books. I don't really know that space at all. Though it sounds fascinating. I do want to be thinking about the world more in terms of ant brains. So that sounds like one I should be picking up.
One thing I'd say is, actually, when you take any networks book, complex networks or whatever, they have these pretty covers. There's always this
network
graph on the cover. Yeah, if you have one of those, it usually makes for a good read. It explains like anything.
You can judge a networks book by its cover, is what you're saying. Awesome. And so, Adrian, how do people follow you after this episode? If they want to glean more brilliant insights from you after the episode, where's the best place to track what you're up to?
So I have no ambition, aspiration to be like an influencer. I'm happy to chat, exchange with anyone. You'll find me regularly on our Pathway Discord. So that's Discord GG/Pathway or through the Pathway things. I'm there. I mean, it's so I'm happy to exchange with anyone from the community who has an interest in any topics that are broadly related to reactive data processing and so on, or nice. to network science topics and how they're being treated. You can find me on LinkedIn. You can find me on Twitter, a bit less.
Nice. All right. Sounds great, Adrian. So that's a very nice offer for listeners. You can reach out to Adrian on the Pathway Discord, and it sounds like at this time he has bandwidth for individual questions. So you can pick his brain. Yeah. Hopefully that's still the case when this episode is published. So thank you so much, Adrian, for making that offer, as well as the hoodie offer going all the way back to the beginning of this episode. And thank you for being so generous with your time as well. And we'll have to check in with you on your journey and the Pathway journey again in the future.
My pleasure entirely, John. Thanks for having me, and hope to see you at a conference sometime soon.
For sure.
That was an incredible episode with a brilliant guest. I hope you enjoyed our conversation as much as I did. In today's episode, Adrian filled us in on how batch processing is associated with training machine learning models at discrete intervals. This could be daily or monthly or whatever, while streaming processing allows for computationally and cost-efficient real-time ML model training. He talked about how reactive data processing allows an application to react to data it hasn't encountered before, handling it seamlessly and potentially saving firms vast sums, such as in financial fraud detection situations or with complex evolving systems, such as the global supply chain network. He talked about how the transformer operations that transform data during data flows can be dynamic or fuzzy when they're powered by machine learning. He talked about how Pathway elected to go with a Python platform interface to be easily usable by machine learning practitioners, while they chose Rust for high performance behind the scenes. And he talked about the big commercial opportunity of filling in the missing bricks for extracting useful insights automatically from data. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Adrian's social media profiles, as well as my own social media profiles at superdatascience.com/669. That's superdatascience.com/669. I encourage you to let me know your thoughts on this episode directly by tagging me in public posts or comments on LinkedIn, Twitter, or YouTube. Your feedback is invaluable for helping us shape future episodes of the show. And if you'd like to engage with me in person, as opposed to just through social media, I'd love to meet you in real life at the upcoming Open Data Science Conference East, ODSC East, which will be in Boston from May 9th to 11th. I'll be doing 2 half-day tutorials. The first one will introduce deep learning with hands-on demos in PyTorch and TensorFlow, and the other tutorial, which is brand new, will be on fine-tuning, deploying, and commercializing with large language models, including models like GPT-4. In addition to these formal events, I'll also just be hanging around and grabbing beers and chatting with folks. It'd be so fun to see you there. All right, thanks to my colleagues at Nebula for supporting me while I create content like this Super Data Science episode for you. And thanks, of course, to Ivana, Mario, Natalie, Serge, Sylvia, Zara, and Kirill on the Super Data Science team for producing another mind-blowing episode for us today. For enabling that super team to create this free podcast for you, we are deeply grateful to our sponsors, whom I've hand-selected as partners because I expect their products to be genuinely of interest to you. Please consider supporting this free show by checking out our sponsors' links, which you can find in the show notes. And if you yourself are interested in sponsoring an episode, you can get the details on how by making your way to johnkrohn.com/podcast. And thanks, of course, to you for listening. It's because you listen that I'm here. Until next time, my friend, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.